Now, what we're going to do today is we're going to look at some more special factors, but we're going to look at this difference of perfect cubes and sum of perfect cubes, and let me show you where it comes from. If you guys recall, you're going to use, it's not exactly FOIL, but let's say it's FOIL-ish. So if you remember, let's look at the first formula here. Formula 1, Formula 2. If I multiply here in Formula 1, remember what we said in the past. We're going to let this be our rows, these terms, and let these terms be our columns. It's not exactly FOIL. It's FOIL-ish, so I have A here minus B, and A squared, AB, B squared. Okay? Let's take a look. A minus B, here's A minus B. Here are my rows. Okay? And then I'll have over here A squared plus AB plus B squared. These are my columns here. And I'll write that in blue. Now we're going to multiply every row with every column. So A times A, we're going to multiply this way. Every row gets multiplied with every column. So you guys know this already. And then A times A, what does that give you? Right, A times A squared, sorry. And let's give the first entry here. Doesn't this give me A cubed? And then A times AB gives me A squared B. Right? Then A times B squared gives me AB squared, and that's my first row with every column entry. Now multiply negative B with A squared, and I get negative A squared B. Negative B with AB gives me negative AB squared. And then negative B with B squared gives me a negative B cubed. Now notice what happens with my diagonal terms here, right? Minus A squared B plus A squared B, isn't that 0? And then minus AB squared plus AB squared, isn't that 0 as well? So we looked at this in the past and we noticed that right in here, the sum of these terms here always gave me 0. And so what am I left with? A cubed minus what? B cubed. Now, in summary, here's what we noted. That when I multiplied here, this is equation 1. A minus B with A squared plus AB plus B squared. What I get is that this is equal to A cubed minus B cubed. In other words, I have a nice factoring formula. I write it as A cubed minus B cubed, A minus B, A squared plus AB plus B squared. Okay? We're going to use this, and this is known as the difference of perfect cubes, okay? Because you see a difference here. And what we're going to see is that A cubed and B cubed are both perfect cubes. So this is called the difference of perfect cube formula, and it's a factoring strategy if I read it in reverse. Okay, you guys okay with that? Now, similarly, this comes from equation 1. Or we called it equation 1. Equation 2 is done the same way. I'm going to take A plus B, and I'll multiply it with A squared minus AB plus B squared. Let's double check. Okay, and this is minus. All right. Again, I have my A plus B row, That gets multiplied to the a squared minus ab plus b squared column. So a times a squared gives us a cubed. A times a minus ab is minus a squared b. A times b squared gives me an ab squared. And then a or b times a squared is a squared b. B times minus ab is minus ab squared. B times b squared is b cubed. Notice again, if we look at these diagonals, we should see something interesting again. We got a squared b and a minus a squared b. Those cancel. Minus ab squared and a plus ab squared. Those cancel. We're left with simply a cubed plus b cubed. So what this gives us is another formula. That's the second formula. We know formula 2. A cubed plus b cubed gives us a plus b times a squared minus ab plus b squared. This is known as the sum of perfect cube formula. Now it's a sum again because you see here sum, and you see here 2 perfect cubes. So this is the second formula we're going to use today. We have the difference of perfect cubes, and we have the what? Sum of perfect cubes, these factoring formulas. Okay? So let me do this for you. First, let's talk about, like we talked about last week. Last week we worked on perfect squares. This week we're going to work on perfect cubes. Now, what I'm going to show you here is this is an exponential. Here is the cube part. Power 3 is cubing. So if I take any base, okay, I'm going to tell you guys this here is my, well, let's do it this way. This is the base. So I have my triangle as the base here. So if I take any base and I raise it to the third power, this whole thing together is known as a, and I'll write it in purple here. This is a perfect cube. So let's look at some examples of perfect cubes. If I take the number 1 and then I cube it, raise it to the third power, what's 1 times 1 times 1? Is that 1? Okay. You know what that means? The number 1 is a perfect what? Cube. What was the base? Because that's going to be important for us. The base is 1. Okay, good. Take the number 2 and cube it. 2 to the third power. 2 times 2 times 2 gives us 8. And that means that the number 8 is a perfect cube. What was the base? 2. Okay, let's take the number 3. Let's cube 3. 3 times 3 times 3. What do we get? That's 27. That means the number 27 is a perfect cube. What was the base? The base was 3. Okay, 4. 4 cubed gives us 4 times 4 times 4, which is 64. And then that means 64 is a perfect cube. The base here was 4. Okay, you guys okay with these? So what you want to do is learn not just your perfect square list, you're also going to learn the perfect cube list because you're going to be using it in your factoring formula. What's 5 to the third power? Do you guys know what that is? That's 125. Good. So 125 is a perfect cube. 5 was the base that we raised to the third power. What comes next? Take a 6. 6 to the third power. 6 times 6 times 6. Anybody know what that is? What's 6 to the third power? Well, it's 36 times 6. 6 times 6, 36. 18. 200 and what? 216. So 216 is a perfect cube, and the base was 6. Okay. Let's try the next one. Number 7. 7 to the third power. 7 times 7 times 7. Now, what is that? Let's see, 49 times 7. 9 times 7, 63. 7 times 4 is 28 plus 6. 343. So I'm generating here numbers known as perfect cubes. I'll just stop right there because, I could do this all day, and we want to get actually started on this. But nevertheless, take a look here. In purple, all of these numbers are perfect cubes. 1, 8, 27, 64, 125, 216, 343. These are all perfect cubes. So if I take anything and cube it, I can call it a perfect cube. Okay, you guys okay with that? Is that simple? Well, we're going to do the same thing now, but with letters. I'm going to put an x as a base. What's x to the third power? Well, it's just x to the third power. You know what that means about this? X to the third power is a perfect cube. What was the base? X. Good. What about y? If I plug y into my triangle and I get y cubed, you know what that means about y cubed? Perfect cube. Okay. My base here is y. Okay, you guys okay with that? Is that easy? All right. Let's plug in 2x. 2x into the triangle here. If I raise this to the third power, you know what that gives me? 2x times 2x times 2x. Wait a minute. We work with properties of exponents. Isn't this 2 to the third, x to the third, which is 8x cubed there, right? By properties of exponents. What does that mean? 8x cubed is a perfect cube. Is that right? What was the base? 2x. Good. Okay, so we could do this with what? We could do it with 3y. Let's take 3y. Let's cube it. Let's use our properties. Right? 3 to the third power. Y to the third power. This gives me 27y cubed. And that means 27y cubed is a perfect cube. What was the base? 3y. Good. Let's take 4y. Let's cube it. 4 cubed, y cubed gives me 64y cubed. Perfect cube. Base is 4y. And we could do this all day long. I could put, like, again, an x here. Let's put 5x here. 5x cubed, 5 cubed, x cubed gives me 125 x cubed. I know 125x cubed, a perfect cube, where the base was 5x, and so on. Okay, you guys okay with that? Should we keep going? Let me show you something too, though. If I put an x squared and I cube it, properties of exponents. You guys already dealt with that. What do I do with these powers? Good. That means x to the 6 is also a what? Perfect cube, by the way. It's interesting. Even if I put an x cubed and I cube that, I get x to the 9th because I multiply my powers. X to the 9th is a perfect cube, and the x cubed is the base. Like for the prior problem, x squared is the base. So you're looking at these perfect cubes, and we're going to be using these things. Okay, you guys okay with that? Let's review the perfect cubes, because we have to know this list. 1's a perfect cube. What else? 8, 27, 64, 125, 216, 343, x cubed, and y cubed. These are perfect cubes. 8x cubed, 27y cubed, 64y cubed, 125x cubed, x to the 6th, x to the 9th. All of these are some perfect cubes. Okay, so now, for example, if we start to work on some of the problems that we have to do, right? They tell us, number one, we're going to have to factor. And question 1 looks like this. Let's take a look. X cubed minus 8. Okay, x cubed minus 8. Now, what do you guys notice here? There's a difference. Is that true? Okay. And now we know x to the third power, what is this? Is that a perfect cube? What is the number 8? Is that a perfect cube? Okay. Notice, can I write 8 as 2 to the third power? Is that right? Where the base here is the number 2. So if you don't believe me, you can say, well, did we do this already? Let's check. Sure enough, we know 8's a perfect cube and x cubed's a perfect cube. So they're there. The base is x and the base here is 2. So here's what I'm going to use. Which formula do we use to factor this? Do you guys know? If you have, let me put it this way for you. I prefer to write the formula this way. You say, I have a cubed minus b cubed, and you say we write that as a minus b, and a squared plus ab plus b squared. We could do it that way. It's not a big deal. But I would rather use this formula. Triangle cube minus the square cube, difference of perfect cubes, is triangle minus square times triangle squared plus triangle square plus the square squared. You see, if I write it, if you notice all the details here, if I write it this way, I'm just keeping track of the base values. What that means here is, what's the base in x cubed? Not x. And what's the base in 8? It's 2. So this would, I put an x here and I put a 2 here. I put an x here and I put a 2. I put an x, 2, and 2. So what happens now is I end up with x cubed minus 2 cubed, which is 8, is x minus 2, x squared plus, I can put x times 2 because that's what's there, and then I got 2 squared, but here's what I want you guys to take a look at. X times 2 and 2 squared, we can simplify that. Meaning, I can write this as x minus 2, x squared, put the number before the letter, 2x, and then square the 2, you get your 4. So ladies and gentlemen, you know what you just did? You factored your first difference of perfect cube problem. This is what it looks like when factored. Bless you. Okay, this is all the work you do to factor the difference of perfect cubes. All right, anybody have any questions on that?
So you don't have to put in the parentheses x minus 2, in second parenthesis x to second power. It's not plus another x.
Yeah, it's plus, it's actually all of these. It's the x squared, it's a 2x, and it's a 4. So you have here a trinomial. This is really a trinomial, 3 terms. Right? And then you have here a binomial, 2 terms. And notice, these are perfect cubes. They're not perfect squares. Okay, so you have a difference of perfect cubes formula and a sum of perfect cubes formula. Let's see number 3. X cubed minus 1. Okay. Now remember, triangle to the third power minus a square to the third power is triangle minus square, triangle squared, plus triangle times square, plus the square to the second power. Okay? I write it with all the bases. In other words, my base here for x cubed, this is, first of all, let's go back. Difference. And then you have what? Perfect cube. 1's a perfect cube. Difference of perfect cubes. All right. What's the base for this perfect cube? It's x. What's the base here for the 1? Well, it's 1 to the third power, so it'll be a 1. So I plug an x here and a 1 here. Okay, let's see what happened. I plug an x here, I plug a 1. An x, and a 1, and a 1. Let's be careful. So what do we end up with here? X minus 1 times x squared plus, what's this x times 1? Not just x, and then what's 1 squared? It's plus 1. So this is a difference of perfect cubes. I'm still going to use the same format with the triangles and the squares, just keep track of my bases, and the rest will just follow. Okay, anybody have any questions on this one? Number 3. Okay, number 5, we have x cubed minus 64. Do you guys know what 64 is really? Isn't that 4 to the third power? Point is, I have a difference, subtraction, and then x cubed is perfect cube. What is 64? Perfect cube. Okay. Yeah, like I said, it's probably, I actually remember this as triangle to the third minus square to the third. Hold on. This difference is triangle minus square, triangle to the second power plus triangle times square plus square to the second power. So what's my base for the first perfect cube? X, good. Wherever there's a triangle, put an x in there. Okay. What's the base for the square? 1, wherever there's a square, put the number 1. The rest is simplifying. So, sorry, 4, you're right, thank you. Put a 4 there. Put a 4 there. Put a 4 there. I get x to the second power. I forgot the 4 over here. The 4 here. Let me go back. Okay. Let's see what we have. X minus 4. And then x squared. Do you guys know what x times 4 is? Can I say that's 4x? Do you guys know what 4 squared is? Isn't that just 16? So it'll be plus 4x plus my 16. We have factored another difference of perfect cubes. So I just identify the bases and use those in my formula. Okay, anybody have any questions on this one? Let's see what a 7 look like. 7 is x cubed plus 27. This is a sum, by the way. And then what are these other numbers? These are what? Perfect cube. 27 is a perfect cube. How do I know 27 is a perfect cube? Isn't that 3 times 3? Good. All right. Now be careful. A sum of perfect cubes looks similar to a difference. Let me remind you guys. You got the base triangle, you got the base square. Square the triangle, triangle times square, square the square. Now here's how we remember the formula. If this is plus, go back. See this here? Let's go back to the formula. Where the formula is, way back here. We got plus, this will be what? Plus. So I want to say to you that when it's a sum, this first binomial has a sum there. And then this next term is always opposite. It's going to be negative. The last term always has a plus. If I go back to the formula here for the difference, notice I have again minus, minus, same term. And then this term is always opposite the first term. So opposite of negative is positive. Just like here, opposite of positive is negative. So opposite of that positive gives you this negative. Let me emphasize that. This is what I'm saying. These terms are always opposite. Okay? So if this term is a plus, the opposite is a minus. If the first term is a minus, the opposite is a plus. Now let's go back to our bases. Here the base is x, and here the base is 3. So I plug in x wherever there's a triangle. And then I plug in a 3 wherever there's a square. So when I factor this sum, we get x plus 3 times x squared. Notice this. X times 3 is really 3x. 3 squared is 9. So I'm going to put 3x here. I'm going to put the 9. Let's see if you guys are paying attention to the signs. If I have a plus here, I have a plus here. Is that true? What's the opposite of the positive sign? There you go, negative. And then the last sign is always what? Positive. There you go. It's another difference of perfect cube factoring problem. Okay, you guys okay with that one? X cubed plus 125. Okay. Notice, isn't 5 cubed 125? So, here's what we have. A sum of perfect cube. Sum of perfect cubes. Triangle. Let's use the formula. I'm going to write it down. Triangle cube plus square cube is triangle plus the square. Triangle squared. Triangle square. Square squared. My sign here has to be opposite, and this always is plus. So again, identify the bases now. This base is x. This base is 5. Wherever there's a triangle, put the x. Wherever there's a square, put the 5. So here's what we get. X plus 5. X squared. Now, what's x times 5? That's a 5x. What's 5 squared? That's a 25. Signs again, go back. Plus, and this better be minus. It better be opposite. Last sign is always plus. Sum of perfect cubes. Okay, you guys okay with that one? Number 11. X cubed plus 1, or we say 1 what? 1 cubed. Let me ask you guys a question here. Can you do this problem if we know sum and then what? Perfect cube, perfect cube. Okay? All right, you guys okay with that one? All right, let me tell you guys here how to do this. Can you do this actually without writing down the formula? Have you done enough of them where you don't have to draw these triangles and these squares? Or do you have to still do it? Because it doesn't matter. If you have to still do it, then do it for all of them. Just do it. But you start to get pretty good at this. Is that right? Okay, good. Now, tell me, let's double check. I got a sum of perfect cubes, so I'm going to put what here? What's my base? Remember, if I know the base, this base is x, this base is 1. I'm going to put x, 1, and this is plus, because these two signs are always the same. Okay? And then what comes next? What do I do with the base now? Square it. And then what about squaring the other base? This is 1 squared. And then the middle is always the product of the two terms. So that's how I see it. I just say, oh, I'm going to take this x term and 1, my two bases, I'm going to multiply. Now, you guys okay with that? Then I just remember the signs. Well, if this is plus, this has to be what? Opposite. That's minus. The last sign is always what? Plus. So, just to clean this up, x plus 1 times x squared minus x, because x times 1 is just x, and then 1 squared is 1, and here is the sum of perfect cubes. This is kind of how I look at all of this myself. This is how I remember what to do. Okay? So I go through the formula. I use the formula, but I first, like you guys, had to write down those triangles and those squares for, you know, a lot of problems, and then I actually just got to the point where I go, oh, I think I could do all these without it. So that'll happen to you guys too, but you're going to have to do enough questions, right? So take a look at this one. X cubed plus y cubed. Let's see if you guys know what I'm talking about. What's the basis? X and y, is that true? Now, you do know, first of all, that you have a sum and both terms are perfect cubes. So I'm going to take that base x, put it here. Take the base y, put it there. Is that true? And then what happens? X squared, y squared. Square the two. And then always remember to multiply the bases. Right here. Take the x and the y, multiply them. Put that in the middle. So this is what I always do for every question. I just have to deal with the signs now. Now, this is going to be plus because these are always the what? The same, is that right? And then this has to be a, what's the next sign? What's opposite plus? Minus. These are always opposites. So ladies and gentlemen, let me clarify this. X plus y times x squared minus xy, and this is always plus, by the way, plus y squared. You are done. Yes?
Do you have to arrange it so like the other one would be like x to the second and y to the second?
Yeah.
So you have to like arrange it like in the formula?
Yeah, exactly. And that's what this is a formula. So it has to be written this way. Exactly. What this is this is also called a factoring formula, the sum of perfect cube formula, difference of perfect cube formula. Last week we did the difference of perfect squares. So this is a factoring formula. You're right. And you write it with this format. Let's try 15. That one's pretty simple. What about this one? This one's a hard one. What do you guys think about this one? This one is a bit tough. Let me do this. Let me point out a detail. First of all, don't we have a difference here? And do we have perfect cubes? I know y cubed is a perfect cube. It's on my list. But what about 8x cubed? Is that on my list too? 8x cubed? Let's check. It sure is. It's right here. Here's my 8x cubed. What was the base that was raised to that power? Isn't that 2x? Didn't we say it was 2x? In other words, the idea here of using the definition to generate perfect cubes, we're going to notice here that this can be written as 2x to the third power minus y to the third power. Okay? Where my base here for that first term is 2x, and the base for the second term is y. So that when I try to factor here, automatically I put down the bases. 2x and y. Okay, you guys okay with that? Now, what goes over here though? This is 4x squared. How do we know? because it goes here is I take the base 2x and I square it. What goes here? Y squared, because I take the base y and I what? Square. What goes in the middle? Multiply the two bases. This is in the middle. 2x y gives you 2xy. So this is how I actually factor these myself. When I go through it, I go, oh, okay, I know what each, I'm using the formula, right? And then I focus on my signs. Let's see if you recall. If this is subtraction, because these have to be the same, but these are always what? Opposite signs. And then the last sign will always be a plus. So to be clear here, we have 2x minus y times 4x squared plus 2x plus my y squared. Yeah, 2xy, sorry. 2xy. Let's write it bigger. And that's how you factor. Okay, you can factor a little bit faster that way. So we're starting to be a little quicker with what we're doing. But this is factoring a difference of perfect cubes. Let's look at 17 here. We get 8x cubed minus 1. Okay, we already talked about the fact that that's actually 2x to the third power. It's right here. Two x to the third power, and this is 1 to the third power. Okay. So let's see what our bases are. Isn't 2x my first base and 1's the second base? So I put it here. 2x and 1. And then this is 4x squared because this is 2x to the second power. And then this is 1 because it's 1 to the second power. The middle term is 2x times 1 are just 2x. So remember the middle term here. We got 2x, we got 1, 2x. What are the signs? What do I put down? Minus, plus, and what? Plus. Good. So I get 2x minus 1, 4x squared, plus 2x plus 1. And yes, this is a factoring formula. The difference of perfect cube formula. All right, number 19. Take a look at this one. 8x cubed minus 27. This one's a hard one. Let's see. Let's see what 8x cubed is. Isn't that going to be, is that 2x again to the third power? And 27, isn't that 3 to the third power? Is that true? Double check. So isn't it good to know your perfect cubes right away so you can, start to work? So you got to know these lists of these perfect cubes. And then again, let's identify the bases. Here we go. 2x and 3. So those bases will go here. 2x and 3. And then I get 4x squared because that's what 2x to the second power is. And then I get 9 because that's what 3 to the second power is. So I square the first term and I square the second term. What's in the middle? 6x. Why is 6x in the middle? Take your two bases and multiply. Good. Let's see if you guys can get the signs. Minus and what? Plus. Always plus. So this becomes 2x minus 3, 4x squared, plus 6x, plus my 9. We factor this. Notice this is known as the difference of perfect cubes. You got two perfect cubes there. Nice factored problem. 21. 27x cubed minus 1. Let's see what this is. Okay, 27x cubed. How do I write that? Do you guys know? Isn't that 3x to the third power? And then 1 is just 1 cube. Okay. Let's find the basis. 3x is a base, 1 is a base. Put your 3x, put your 1. And let's see if you're awake. What goes here? What comes next? Isn't that 9x squared? Because isn't that what you get when I take the base 3x and I square it? And isn't this going to be 1 because that's what 1 squared is? What's in the middle? 3x. Good. Multiply the bases. 3x and 1. You got 3x. Okay, let's handle the signs. Minus and what? Plus. This is always a plus. Good. 3x minus 1. 9x squared. Plus 3x plus 1. Okay, you factored this. What is this one? What's this formula known as, by the way? Difference of perfect cubes. That's the difference of perfect cubes. 27x cubed plus 64. This is not a difference. This is a sum of perfect cubes. So we're going to write this as, we've got to identify the basis. 27 cubed, I think we've seen that. Isn't that 3x to the third power? And 64. Isn't that 4 to the third power? We've seen that before, 64. What are the bases? 3x and what? 4. So I'm going to put my bases down. 3x, 4. And then what comes next? I'm going to say 9x squared because this is where I get my 3x to the second power. And this is 16. You say why? Because I square that second base. So I square the first base and then I square the second base. And then in the middle we have 12x because you multiply that 3 and that 4. Gives you 12. Let's find the signs. If this is plus, this is plus. And this is opposite, then we have always plus. 3x plus 4 times 9x squared minus 12x plus my 16. And we're done. What do you guys think? You okay? You just have to do how many of them? You do a lot of them. That's how you learn this. Until you pass out. That's right. How do you get strong with push-ups? Do a lot until you pass out. How do you get strong with pull-ups? Do a lot until you pass out. There's a guy that did thousands of pull-ups. You guys see that? Yeah. He didn't do them all at once, though. That's kind of interesting. He took a break, and then he did some more. He took a break. Same thing with factoring. Do some more, then break, do some more, and then break until you factor in your sleep. Is that amazing? Because you know what your brain's doing? Your brain is firing up neurons in a particular order, in a particular pathway, over and over again. And when it does that, it trains itself to remember what to do. So you got to train your brain. And the only way you can do that is doing this over and over again with different problems. Isn't that crazy? You think your brain doesn't have to be trained. But your brain has to be trained just like everything else. So let's try this out. Let's see if you guys see the shortcut, right? First of all, is this a sum or is this a difference? Sum. Sum of perfect cubes. 8x cubed is really what? Isn't this 2x to the third power? And then my y, well, that's just y to the third. Let's see what the bases are. 2x and what? Okay, let's write down the bases. 2x and y. My brain has fired up those neurons, so I know those bases always go there. And then what do I remember? Square the first base. So in other words, this is 2x squared. And then square the what? The second base. So this is y squared. And then multiply the bases, 2xy. My brain has already done this over and over again, so I know that's the product. I just handle the signs. Plus and plus, always the same. This is opposite, always plus. So your final answer is 2x plus y, 4x squared minus 2xy plus a y squared. You have factored this sum, it's a sum there, of perfect cubes. (27) 8x cubed plus y cubed. All right, let's see. First of all, sum. And then you have perfect cube, sum of perfect cubes. I just did that one. Huh.
You skipped 25.
Ah, let's say this. I skipped 25. Thank you. This is actually 27. Thank you. 25 is going to be 27x cubed. Or 27y cubed. Sorry. This again is a perfect cube, so these are switched. Okay. No big deal. They're very similar, slight difference. Let's see if you guys see the difference. Isn't this 2x to the third and this is 3y to the third? Is that true? 27y cubed, isn't that 3y in parentheses to the third power? Okay. Plus. Here's my basis. 2x and 3y. Where do I put them? 2x, 3y. You okay with the bases there? What do you guys think? Is that okay? And then, what's 2x squared? 4x squared, because this is really 2x, the second power. And then what's 3y squared? 9y squared, because that's 3y to the second power. So double check. What goes in the middle? See if you're awake. 6 what? 6xy. Remember what we did? You take the 2x, you take the 3y, you multiply them. That's 6xy. Handle the signs. Plus, plus, opposite, plus. So, 2x plus 3y, 4x squared minus 6xy plus 9y squared. Here we go. You are what? 25 and 20 what? 7. Whew. (29) x cubed minus 27y cubed. We're almost there. Difference. What are these? Perfect what? Cubes. Okay. This is x to the third, and this is 3y to the third. Is that right? Let's identify the bases. X and 3y. X, 3y. What do I do with the first base? Square it. What do I do with the second base? Square it. That was 3y to the second power. What do you do with the terms? Or the bases? Multiply, and what do you get? 3xy. Okay? Handle your signs. What did the sign say? Minus, minus, opposite. This is always plus. X minus 3y, x squared plus 3xy, plus 9y squared. You are Done. 29. $31. X cubed minus 125y cubed. Okay, you have a difference and perfect cubes. So what is 125 cubed? Or 125y cubed? Isn't that 5y to the third power? Okay. Let's see if we could do this. What's my base? You guys know? What are my two bases? First base is x, second base is 5y. X, 5y. And then x squared, 25y squared, because I squared the second base. What is the product now of x and 5y? What do you got? 5xy. What are the signs? Minus, that makes this minus. What's opposite the minus? Plus. And then this is plus, so we get x minus 5y times x squared plus 5xy plus 25y squared. Okay? And you are done.